All right, so we're going to begin our going over the quizzes for the binomial, geometric, normal, and distribution of means. And we're going to begin with the exit ticket quiz that we took on Thursday and Friday of last week. So a company that manufactures smartphones developed a new battery that has a longer lifespan than that of traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan is approximately normal. As soon as I see that word, I start thinking normal, with mean of 30 and a standard deviation of 8 months. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost if the battery no longer works within 24 months from the date of purchase. So, question 1, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Justify your answer. So, they gave me a percent. Whenever I'm working with a normal curve, I probably need to be thinking about my apps. And remember, if they give you an app, you're working with an inverse norm. If they ask you for an app, then you're going to be using a norm CDF. Here they gave me an app, and what I mean by an app, that's area, percent, or probability. Well, they gave me a percent, so I'm probably going to be working with an inverse norm, and because they gave me an app, and we know that this is normal. So they told me that this was normal with a mean of 30, and they told me my standard deviation. And where did that go? Was standard deviation was 8 months. And so they want to go, and how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Well, since it's normal, I go ahead and write this down every single time. This is just my organizational tool. It lets me know what I have, what I need, and what I might be looking for. So I know I have an 8 for my standard deviation. I know I have a mean of 30, and I know I'm looking for some x. I'm looking for some x where this area right here is 0.25. And I don't mean to waste your time, but I know that this is half, so 0.25 is on this side. So I need some value that's going to be below 30, and I'm looking for this. Unfortunately, I don't have a z. But through an inverse norm, I can do an inverse norm of 0.25 and get it. Now, please remember, all z's have a mean equal to 0 and a standard deviation equal to 1. So when I go about doing this, second vars, inverse norm, my area, 0.25, my mean is 0, my standard deviation of 1, and I end up getting a negative z-score of negative 0.6744. Now you can round that up. I prefer to truncate, personal preference, and it's not going to matter on the test. So negative 6.6744 times 8, add 30 to it, and I end up getting 24.604. So x equals 24.604. And that's my answer to part A. So suppose one customer who purchases the warranty is selected at random. What is the probability that the customer selected will require replacement within 24 months of the date of purchase? All right, so once again, I'm going to go back to, just because I make a habit of this, I have a normal curve, mean of 30, standard deviation of 8, z equals x minus mu over sigma, will require replacement within 24 months. Well, using my complicated elementary math, I know 24 becomes before 30, So I'm going to mark this here. And anything less than 24, I have to pay for. All right, or I have to warranty. It's going to cost me money. Notice they're asking me what is the probability. So they're asking for the app. So this clues me in that I'm going to be working with a norm CDF. So I need the probability that X is less than 24. Again, we're looking for probability. So this clues me in that I'm probably working with the norm CDF. Plugging in, that's the probability that Z is less than 24 minus 30 over 8. All right. Now, when I look at this, this is going off to negative infinity. So I can go to my norm CDF, second vars, norm CDF. My lower bound is negative infinity, which I can fill up with a bunch of 9s. My upper part of my shading, upper part right here, is 24. My mean is 30. And my standard deviation is 8. And I end up getting a probability of 0.2266. So what this is telling me is the probability that an individual battery would have to be replaced is about 22, 23%. It also tells me that 22 to 23% of the entire population of batteries lasts less than 24 months. So I had a question. The question was, how do I know if I'm looking for a Z-score or looking for the X? Because the previous one I was looking for, I found the Z-score first, and here I plugged in an X. What clued me off? Well, they told me here that I had that I was looking for the probability. So if I'm looking for the probability, if I'm looking for the probability, then I'm doing a norm CDF, which means they need to be giving me my X. They had to give me my X. On the other hand, in the previous problem, they gave me a percent. All right, so they gave me a percent, so I'm going to have to solve for my Z-score first so that I can find my X. So anytime they give you a percent, they gave you an app. If they give you an app, it's inverse norm. If they give you the app, it's inverse norm. All right. Letter C, the company has a gain of $50 for each customer who purchased the warranty but does not require a replacement. The company has a loss of $150 for each customer who purchased a warranty and does require a replacement. Well, in our previous problem, we found out that 22%, 23% of the batteries have to be replaced. So here's what we know. 0.2266. 23% of the batteries are going to cost them $150. And so I'm making it negative because it's costing them $150. But the complement of that, 1 minus 0.2266, is going to make them $50 a piece. So this is going to make them $50, all right, which is, in my head, doing some quick math, is about 77%. And here at about 23%, we're going to lose money. So let's go ahead and do this, all right? So this is going to be 0.2266. I guess I should put that on the screen so you can see it, times negative 150 plus parenthesis 1 minus 0.2266, close parenthesis, times 50. Once again, that was just the complement. So these are the ones that are going to cost me money, 22%. These are ones that are going to make me money. When I do my expected value, I find out that I expect to make $4.68 on average for each warranty. Now, if we were doing a written test, you would need to say that what does that mean? In the long run, or if we did this over and over again, we would expect to on average to make $4.68 on each warranty that we sold. because we're going to lose $150 on 23% of them, but on 77% of them, we're going to make $50 for an average gain of $4.68. Obviously, we're not making $4.68 on any battery warranty. We're only we're making that in average, because we're either losing 150 or we're gaining 50, but we're never ever actually earning exactly that. It's just on average or in the long run that we're getting that. All right, letter D. In how many months from the date of purchase is it expected that 95% of the batteries will no longer work? Justify your answer. Well, once again, we're still working with the normal curve. So I'm going to go ahead and draw this right here. There's my mean, my standard deviation's 8. That 95% will no longer work. Well, that means we started at 0 not working, and we went all the way up to 95%. So I'm shading this way. And this area is 0.95. This is negative infinity. And once again, Z equals X minus mu over sigma. I start plugging in. Now, and I plug in and I go, okay, I have a mean of 30. I have a standard deviation of 8. And I notice they gave me one of my apps. And since they gave me an app, I'm thinking this should be an inverse norm. And as it turns out, I need a z-score. So I need to do a second VAR's inverse norm of 0.95. Please remember, all z's have a mean equal to 0 and a standard deviation equal to 1. So second VAR's inverse norm, 0.95, mean is 0, standard deviation of 1. And I end up getting 1.644. And it makes sense that it's positive because I'm above the mean, so it makes sense I'm positive. And what I'm looking for is that value. I'm looking for that X value right here. So I'm going to go ahead and solve this by algebra. So times 8 plus 30. And I end up getting 43.1588. And what this means is 95% of the batteries have quit working by 43 months. So by 43 months, 95% of the batteries have quit working. Okay, so what percent of the batteries no longer work after 36 months? So what percent of the batteries no longer work after 36 months? So once again, we have our mean of 30, our standard deviation is 8, 36 is above it. And they say after 36, not before 36. So I'm thinking after is going to be shaded up and to the right. So once again, Z equals X minus mu over sigma. Now, nowhere in here they did not give me an app. They asked for an app. If they ask for a percent, norm CDF. Since they asked for percent, remember, if you ask for an app, if you ask for an area, percent, or probability, then it's probably a norm CDF. So our minds wrapped around thinking that. We want to know the likelihood that is greater than 36, because it has to be after 36. So I want the probability that Z is greater than 36 minus 30 over 8. So here we go. Second VAR's, norm CDF. My lower bound is 36, because that's the lowest part of my shading. I know it's not very pretty, but I shaded to infinity. So I'm gonna load this up with a bunch of 9s till I get tired. Mean of 30, standard deviation of 8. So E, what percent of batteries last, a percent of no longer work after 36 months. So this is that value. All right, so what percent of batteries no longer work after 36 months? So I can see where this was a confusing question, because what it's technically asking for is 1 minus that, which would be 0.77, or 1 minus that. And here's why. 23% of the batteries last longer than 36 months. 77% of the batteries no longer work at 36 months. And that was that's not the best phrased question. I have to apologize for that. I'm going to put this on pause. Ms. Lamb and I may need to have a little discussion. Oops, did not pause it. Okay, so what percent of the batteries will work between 24 and 30 months? Well, this is kind of nice. So once again, our mean is 30, our standard deviation is 8. We're interested in this value, that shaded area. So we want the probability that 24 is less than X is less than 30. That's what we're looking for. Now, Z equals X minus mu over sigma, because that's habit. We should be writing that down every time. And it says what percent. So they didn't give me for an app. They asked me for an app. So if they asked me for an app, I'm probably looking at a norm CDF. Here I get to do it twice because I have 2 values. And what I learned in elementary school, it's easier to subtract the small number from the big number. So I'm going to set it up this way. The probability that Z is less than 30 minus 30 over 8 minus the probability that Z is less than 30 minus 24 over 8. Now, if you recognize the shortcut, that's fine, but I'm not going to use a shortcut. Obviously, this becomes 0, okay? But I'm going to go ahead and work this out through the calculator. Second bars, normal, CDF. My lower bound, the lowest part I shaded to was 24. The upper part I shaded to was 30. My mean was 30. My standard deviation is 8. And I end up getting 0.2733. I end up getting 0.2733. That's letter F. All right, so the next several of these are using the answer in part B. And the answer in part B was 0.2266. So using your answer in part B, what's the probability that the first customer to have to replace their battery is the 7th customer? I see the word first, and I immediately think geometric. It may not be, but that's what I'm thinking it is. So what's the probability that the first customer to have to replace their battery is the 7th customer? So the first person replacing it is the 7th customer. So that means I'm going 1, 2, 3, 4, 5, 6, 7 blanks. And this one is replacing it, because that's the probability of replacing it. And then these are not replacing it. And so that's 1 minus 0.2266. And since I can't do any math tonight in my head, at least not correctly, I get 0.7734. So 0.7734 times 0.7734. I get smart at that point. I go, oh, it's 0.7734 to the 6th power times 0.2266. Hold on just, all right, times 0.2266. So we say it's a geometric, and since it's a singular value, it has to be the 7th customer. This is a geo PDF. Our probability is 0.2266, and our X value is 7. So second vars, geometric PDF, 0.2266. Our X value happens to be 7. Well, if I hit it one more time, it will be. So in this case, the probability that the first customer to have to replace their battery is the 7th customer is about 5%, a little less than 5%. So 0.0484 or about 5%. Okay. Okay, so the question came up in the chat, why did I use a PDF here as opposed to a CDF? And I think that's a great question. So basically, it could have been the first person, the second person, the third person, fourth person, fifth person, sixth person, seventh person. All right. So the first person to replace their battery is the 7th person. So since I'm only circling one number, since it's specifically the 7th person, that makes it a PDF. A CDF, I will have to circle multiple values. So the CDF requires the circling of multiple values. A PDF only requires the circling of one value. This. So the question is, I knew it was a geometric PDF really quickly, and here's why. They said the word first. That indicates to me that it's probably a geometric, not necessarily, but probably, and that's specifically on this particular person. So specifically this person, it's a PDF because it's a singular value. A singular person is always a PDF. A singular occurrence is always a PDF. Now, I'm continuing until I find the first. The definition of a geometric is continuing until we find the first. That is a contrast in the binomial that really doesn't care about when the first occurs. It just says you're going to do it this number of times and count how many successes you have. So we could have had, we could have had 7 trials and had 3 successes, or 0 successes, or 5, or 1. But a binomial has a specific number of trials where a geometric is going to continue until the first success. So the previous question was a geometric PDF, and in contrast to that, we're going to look at this question. So using your answer in part B, which we already said part B had a probability 0.2266, what is the probability that the first customer, so this, because it says the word first, because it has the word first, I'm thinking this is probably a geometric because of the word first, to have to replace our battery is in 7 months is among the first 7 customers. Among. So here we go. Among the first 7. So that means it could have been the first one, the second one, third one, fourth one, fifth one, sixth one, 7th one. It could be any of these values. The first one could be number 1 or number 2 or number 3. Because I'm circling multiple values, I think this is probably going to be a geometric CDF. Now, work on this one is a little bit weird. It is. So basically, we have to show, this is where we're going to do the bookends, because technically it's the PDF of 1 plus the PDF of 2 plus the PDF of 3 plus the PDF of 4, all the way to the PDF of 7, and quite frankly, I don't want to do that. So I'm just going to do first plus last. Well, the probability that it happens on the first one is 0.2266 plus ... plus 0.2266. This will always be to the first power. And this is going to be 1 minus 0.2266 because it's the complement. And it's going to be 7 minus 1 is 6 because it's the number of people I talked to, which was 7. So 7 minus 1 gives me 6 because these two exponents need to sum up to 1. Now this is going to be a GO CDF. Our probability is 0.2266 and our X value is 7. So second bars, geometric CDF, probability 0.2266, X value 7. And we end up getting 0.8344. So the probability that the first person has to replace their battery, first person replaces their battery is among the first 7 people is about 83%. About 83% of them have to replace it. And the first is going to be one of the first ones. There's an 83% chance. Using your answer in part B, gosh, once again, 0.2266. What is the probability that 2 out of 7 customers have to replace their batteries? Oh, wait a second. We're no longer looking for a first. We have a specific number of trials. And our specific number of trials is 7. The fact that I have a specific number of trials makes me think binomial. Whenever I have a binomial, I make a number line. I always do. 0, 1, 2, 3, 4, 5, 6, 7. Probability that 2, I'm only circling one value. Because I'm only circling one value, I believe this to be a PDF. All right? So I need to set my binomial equation up, which is 7 choose 2, 0.2266 squared times 1 minus 0.2266, and 7 minus 2 is 5. Now there's a couple of different ways to write that general formula. N choose x, p to the x, 1 minus p or q to the n minus x. And sometimes they use k. Sometimes we substitute k in for x. But the calculator is using x. So we're doing a binom PDF. And by the way, this is what your work looks like, right? The part that I starred. That's what your work looks like. Binomial PDF, trials, 7. Probability, that does not look like a 7. Probability is 0.2266. And our X value, our number of successes is 2. And I don't expect you to memorize those values like that, but it's in the calculator program. It'll just ask you for them. Trials is 7. Probability 0.2266. X value 2. And I end up getting 0.2983. All right, so back to this problem. Question is, why did I use a PDF versus a CDF? Why did I use a binomial as opposed to geometric? I'm going to start with answering the binomial, why I used a binomial as opposed to a geometric. If it had been a geometric, they say, what's the probability of finding the first one out of 2 or the first one out of 7, all right, the first person that had to replace their battery? They didn't ask me that. They said, hey, we're going to go to 7 people. What's the chance that you have 2 failures out of 7? So we have 7 trials because we're sampling from 7 people. We're going to talk to 7 people. We're not going to wait till we find the first one. We're going to talk to 7 regardless how many there are and go, hey, and then we're going to find out what's the chance that we had 2, not 1. So because of that, I'm thinking that makes it a binomial because we have a specific number of trials. Now, when I make my number line 0, 1, 2, 3, 4, 5, 6, 7, this says the probability that 2, not 3, not less than 2, not more than 2, not at least 2. It says what's the probability that 2. So because it's that 2, I can only circle one number. If I'm only circling one number, it's a PDF. All right, if I'm only circling one number, it's a PDF. Okay, so this one's going to contrast very nicely with letter I. It says, using your answers in part B, what's the probability that at least 2 out of 7 customers have to replace their batteries? First off, because I have a number 7 and I'm not looking for the first, this is 7 trials. I'm talking to 7 people, regardless whether it's the first one or not. So because I have 7 trials, this clues me in, it's into a binomial. Now, there's a couple things that clue me into this is a binomial CDF, but I'm going to always go back to that number line just because I think that is a safe bet. At least 2 out of 7. That means it could be 2, it could be 3, it could be 4, it could be 5, it could be 6, it could be 7. In other words, I want the probability that X is greater than or equal to 2. That's what I'm looking for. So because I have multiple values, I'm going to go ahead and make a note to self. This is going to be a binomial CDF. Now, a CDF is just a sum of all the PDFs. So I really need to do a PDF of 2 plus a PDF of 3 plus a PDF of 4 all the way to a PDF of 7. And I guarantee you I'm going to make an error if I do that. So we're going to bookend this. We're going to do the smallest, and then we're going to add the largest. Well, the smallest number I want is 2. I'll put this 1, make sure this 1 is out there. Okay, so 7, choose 2. And this is going to be 0.2266 squared times 1 minus 0.2266. 7 minus 2 is 5. I had a student ask me just a few minutes ago, could I just put in 0.7734 right there? Absolutely, absolutely can. That's perfectly fine. So you can go ahead and simplify that real quickly. And then my largest one is going to be 7, choose 7, and 0.2266 to the 7th power times 1 minus 0.2266 to the 0 power. Okay? So that's showing my work. This right here gives me credit for doing my work. So what am I going to do in my calculator? This is where things get tricky. All right? We have an at least. In other words, anytime we do not circle 0, we need to do a 1 minus. Anytime you don't circle 0, think about doing a 1 minus. So 1 minus what? Well, I'm going to take away what I don't want. So you go, okay, I want to do 1 minus the binomial CDF, and you're inclined to say 2, and I'm like, no, we want 2, so don't take 2 away. You can don't take away what I want. You can have what I don't want. Well, what don't I want? I don't want 1. So 1 minus the binomial CDF, trials is 7, probability is 0.2266, and the X value that I don't want happens to be 1. So in the calculator, 1 minus second vars, binomial, CDF, trials of 7, probability is 0.2266. I'm subtracting out the highest one I don't want. I want 2, so you can't take away 2, but I'll let you take away the 1 because I didn't really want it. When I do that, I end up getting 0.4950. I end up getting 0.4950. All right. So I had this question about, hey, when I did letter G, all right, which was a geometric. I didn't include 0, but I did over here. Why did I include it, not include it with a geometric, and why did I include it with a binomial? Well, with a geometric, you're looking for the first success. And the first success cannot happen on a 0 person because there is no such thing. There is nothing there. So I can't have my first success there. My first success either has to be 1, 2, anything greater than 1, I could have a success. With a binomial, I'm not looking for my success. I'm counting the number of successes. And sadly, I could have 0 successes, okay? I might have no successes. I mean, that'd be very sad. We'd all cry. But it's possible we'd have 0 successes. So I could have 0 successes or 1 success or 2 successes, whereas the geometric, the first success will always occur on the first person. Or could be the first person. It doesn't mean it will occur then, it could occur then. Okay. Using your answer, actually you don't need your answer, you don't need that part. This you don't need, scratch that out. What is the probability that a group of 9 batteries have an average life of at least 35 months? What is the probability that a group of 9 batteries have an average life of at least 35 months? Well, what was the average? Well, the average, we had a mean of 30 and a standard deviation of 8. And I got that from way up above a long time ago. We probably forgot it by now. And they're asking for average. So this makes me think X bar. Okay? And this says at least 35 months. So I'm thinking maybe I should draw this picture. I'm not 100% sure, but I'm going to start there and see what happens. So I draw this and I go, okay, I have a mean of 30. I have a 35 and I want to last at least this long. So at least means I'm shading in this direction, which means I'm shading to positive infinity. So it's like, okay, normal. Z equals X minus mu over sigma. And I started with that, but they said average. So, and I have a sample size. Average sample size, distribution of means. Okay, X bar sample size, distribution of means. And we know the underlying distribution is normal. So this is going to be divided by the square root of 9, or square root of n, excuse me, I just write as the formula. So I want the probability that X bar is greater than 35, because this was supposed to be an average. So that's probability that Z is greater than 35 minus my mean of 30, standard deviation of 8, divided by square root of, over there I write the square root of 9, and over here I write the square root of n. All right, so second vars, normal, CDF, lower bound, lower part of my shading is 35. The upper part of my shading is infinity. My mean is 30. My standard deviation is 8 divided by the square root of 9. And if you're not in my class, I like to do 9 raised to the half power. I like to do n to the half power. There's nothing wrong with using the square root key. I just mess it up. So I use the caret to 0.5, just my preference. And so I end up getting 0.0303 or 0.0304, depending on people's rounding of that. All right, I'm going to slide that up just a little bit so you can see that. And what clued me in that this was a normal is because we were talking about the average. Because we're talking about the normal, because we're talking about an average, that makes me think X bar, and I have a sample size. And because I have a sample size and an X bar, I'm thinking, okay, it's this formula, but I can only use this formula if n is greater than or equal to 30, or the underlying is normal, and they told us the underlying was normal, so we're good to go. Even though our sample size wasn't big enough, the underlying the underlying distribution was normal, so we were okay. Okay, real quickly, I knew this was normal because they told me it was normal way at the top of the page. However, if my sample size had been 30 or bigger, it makes all the averages normal. So if this had been, it's not, but had this been 35 or 30 or 31 or 100, it would make any average, any distribution of averages normal. But since it wasn't, I needed for my underlying to be normal, and they told me it was, and that's why I could use the z equals x bar minus 3 formula. Excuse me.